So we're going to start our study of probability and the basics of variance and standard deviation, okay? Now, before we start, you need to understand, let's say I work at the zoo, okay? And I am the zookeeper for the snakes. And I want to find out what the average age of all 6 snakes at the zoo are. So I got 6 snakes at the zoo, right? And let's say one of them is 1 year old. Another one is 6 years old. I got one that's 10 years old. I got another one that's 4. I got one that's 5. And I got one that's 14. Okay? So those are the 6 ages of the snakes at the zoo, right? Now, since that's all the snakes at the zoo, that's my total population, right? But so this is my population, isn't it? Say population. Okay? And so what we're going to do is we want to know what the mean, and this is the symbol for mean. This is the symbol for mean of a total population. So if we were to calculate the mean of the population, we would just add up all the ages and divide by how many there are, right? So let's add them all up. And so my mean is the total of them, 40, divided by how many there are, 6, which equals what? 6.6 repeating. So the average age of the snakes at the zoo is 6.6 repeating, right? Okay. But here's what we want to know. We want to know more than just the average age. Variance and standard deviation are sort of a measure of how far each snake is from the average, right? So how many years away is this snake from the average age? It's like 5.6 years away, right? So like you said, like 5.5 years. So this snake is almost right on the average, isn't it? This snake is older than the average by about 3.5 years. This snake's younger than the average by about 2.5 years. This snake's a little younger than the average by about 1.5 years, right? But now this snake's mega old compared to the average, right? Well, variance and standard deviation kind of give us a way to display how far away most of the animals are from the average. Okay? So let me show you how to calculate the variance. Now, variance is symbolized by the symbol sigma squared. Sigma squared means variance. Okay? And then sigma means standard deviation. Okay, now it may be better if I wrote my sigma like with a straight line and then a circle, kind of like that. Okay, so sigma, this is the letter sigma. Okay, so sigma means standard deviation, and sigma squared means what? Variance. So let's calculate the variance first. Okay, now here's how you calculate variance. Variance is you take the number in your population right here, so 1, and you subtract it from your mean, which is 6.6 repeating, or 40 over 6, and then you square it. And you add them all up, okay? So I need to do that 5 more times. So I'll say plus 6 minus 40 over 6, all squared, plus what? 10 minus 40 over 6, all squared, plus what? 4 minus 40 over 6, all squared. Why am I using 40 over 6 instead of 6.6 repeating? Because it's exact. Yeah, I don't want to, every time you round and then you calculate by rounding, you lose a little bit of your accuracy. Okay, and then I've got 5 minus 40 over 6 squared plus what? Plus 14 minus 40 over 6 squared. And then I'm going to take all that and divide by how many pieces of my population there are. Well, how many do I have in my population? 1, 2, 3, 4, 5, and 6. Now, capital N stands for the number of items in your population. So in this case, capital N would be 6, right? That's the total of number of items in your population. So what are we going to divide by here? 6. Okay? 6. And so let's calculate each of those. So for the first one, for 1 minus 40 over 6 all squared, I got 289 over 9 plus. Now, really, I got 32.11111 repeating, and then I press math enter, right? So then let's do the second one. All right, and so when I did 6 minus 40 over 6 squared, I got 0.444, and I pressed math enter, and it told me 4/9. So 4/9 plus, now I need to do the third one, 10 minus 40 over 6 all squared. And so for the third one, 10 here, I got 100 over 9. And the reason I'm using fractions instead of decimals is because I don't want to round until the very end. Plus, and now I'm going to do 4 minus 40 over 6 all squared. All right, so when I did 4 minus 40 over 6 squared, I got 64 over 9 plus, and when I did 5 minus 40 over 6 squared, what do I get? I get 25 over 9. And whenever I do 14 minus 40 over 6 squared, what do I get?
484 over 9.
What is it?
484 over 9.
484 over 9. And then that's all over what? 6. And now I need to add up each of those fractions. Now, when I put those fractions in the calculator, I need to put them in parentheses. Okay, so when I add all of these top fractions right here, what I get is 322 over 3, 322 over 3, and I'm dividing that all by what? So I'm going to take in my calculator and I'm going to type in parentheses 322 over 3, close the parentheses, and then I'm going to divide by 6. So I'm doing it like this. I'm putting my 322 over 3 in parentheses and dividing by 6, and I get 17.8 repeating. 17.8 repeating. And so if I press math enter, that's the same thing as 161 over 9. Now what we're saying is our variance is 17.8 repeating. Okay? Our variance is 17.8 repeating. So I'm going to write here equals 17.8 repeating. Now, how do you get rid of a squared? Square root it. So let's square root the variance. Let's square root the variance. And when you do it, go square root of, and then in parentheses put 161 over 9. Don't use the decimal. And you get 4.23. So our standard deviation is 4.23, right? So if you calculate the variance and you want to get rid of the squared just so you have sigma, you can square root your variance and it'll provide you with the standard deviation, right? Now what we're saying is on average, each snake was about 4.23 years from the average. Does that make sense? So our average was like 6.5 years old, right? Our average age of the snakes was like 6.5 years old. And when we calculated the standard deviation, we're saying on average, each snake's about 4.23 years away from the average. Does that make sense? That's what standard deviation is. the distance from the what?
Blank.
Standard deviation is the distance from the average. Say it. Standard deviation is the distance from the average. Say it. Yeah, and it's the average distance. So you could say, like if somebody came to you and said, about how old are all your snakes? You would say what? About 6.5 years old. And they'd say, well, how far away are most of the snakes from that?
About 4.
About 4.2 years away, right? That's what standard deviation is.